Hello my dear students. So today we will be having a continuous discussion on the previous sessions of this 100 days challenge where we are discussing about solutions, right? So we have seen the basic definition of solutions and types of solutions, and also we have discussed about Henry's law, that is what effect of solubility of gases in the solutions, I mean in the liquids, the solubility of gases in the liquids explained by Henry's law. Then next we have studied Raoult's law also in the last class. Right now we have discussed about Raoult's law also. Now those solutions which are obeying Raoult's law at all compositions, at all temperatures are considered as ideal solutions. Now what I am saying, the solutions which are obeying Raoult's law at all compositions and at all temperatures are considered as ideal solutions right now. So what is this Raoult's law we discussed in the last class? See, on that day we have discussed these questions, and then next we have solved those few questions also. See, Raoult's law is given by P total vapor pressure of solution is equals to vapor pressure of A and B. If a solution which is a binary solution made up of A and B, I am saying. So this AB, let me change the color. So A and B are the two components of the solution. Okay, let us consider it is a volatile solution. Now total pressure of that solution will be equals to partial like vapor pressure of A in that solution and vapor pressure of B in that solution right now. And then next we are considering this as vapor pressure, total vapor pressure of solution is equals to, I can write this as vapor pressure of A, component A in the solution. Let us say this is a beaker containing these two components. So this is a solution. So now in this we have some amount of A. Let us represent that A with the mole fraction of A, and I can also represent mole fraction of B like this, the composition of A and B in terms of their mole fractions. And now we know the pure A, that is what pure A I can represent as P naught A is a vapor pressure of this component A before mixing. Okay, now before adding into that is the vapor pressure of pure A, I can say P naught A, and similarly vapor pressure of pure B I can write P naught B right now. So now what is the vapor pressure of A? Vapor pressure of A in the solution. See, P naught A is the vapor pressure before mixing in order to make this solution. So after making the solution, the vapor pressure of A is how much, means you should write P naught A, it's pure vapor pressure multiplied with its mole fraction in this solution like this. Similarly PB will be equals to vapor pressure of B in the solution is equals to P naught B into its mole fraction. Okay, so I can write P naught A XA plus P naught B XB, P naught B, P naught B, P naught A, P naught B into XB like this. Okay, so this is a Raoult's law. Now this solution, those solutions which obeys this Raoult's law is considered as ideal solutions. Okay, so now we have, based on this we have two types. One is ideal solutions, and another one is non-ideal solutions, Okay, now again these non-ideal solutions, how can we define ideal and non-ideal? Solutions which obeys Raoult's law at all compositions and at all temperatures is considered to be ideal solutions. If they do not obey this Raoult's law, considered as non-ideal solutions. Again these are of two types. One is positively deviated from Raoult's law, and some of them are negatively deviated from Raoult's law. See, these topics are very important and very easy topics that should be learned by every student. Okay, yes, I am looking into the comment box. Yes, you can write in the chat box, I am looking into it. Yes, hello dear. Yeah, so now what I told you, if they follows Raoult's law, ideal, if not non-ideal. Non-ideal are again positively deviated solutions and negatively deviated solution. Now this Raoult's law will be having P total equals to PA plus PB. This is followed here. But here for these positively deviated solutions, so they will be having vapor pressure, the observed vapor pressure. If we calculate them, the vapor pressure of that particular components, if we calculate theoretically, let us say P calculated, this is theoretical calculated. Now I am saying P observed, it means this is practically observed by doing some experiment. So vapor pressure observed for that particular solution will be greater than its calculated, theoretical calculated vapor pressure. Hope it is clear. So this is what happens in the positive deviated solutions. Now what you will observe in the negatively deviated solutions? Now practically observed vapor pressure is there now, that I am writing it as P observed, vapor pressure of solution observed will be lesser than the vapor pressure of that solution calculated theoretically. So I am writing P calculated means that is a theoretical calculation. Okay, so this is the scenario, observed vapor pressure will be lesser than the calculated theoretical vapor pressure. Okay, so this will be in the case of negative deviation, and positive deviation means observed vapor pressure will be greater than its calculated theoretical, calculated means theoretical vapor pressure of that solution. Hope it is also clear. Now I will make it little more clear with the diagram. So what is the diagram we have for, graph we have for this Raoult's law. So we know this is a vapor pressure will take on y-axis, and here the composition of A, that is chi A taken as 1, and mole fraction of A 1 and mole fraction of B as 0. Here mole fraction of A is 0 and mole fraction of B will be 1. Hope it is clear. Now these things we discussed in the last class also. Now let us say this is the vapor pressure of pure A, okay, P naught A I am saying, okay, and let us say this is the vapor pressure of pure B, I am saying P naught B. Now vapor pressure of A, PA I want in the solution, so that we will get a curve something like this, we discussed in the last class also, and for this we will get a curve like this. Okay, so P total, if I want, P total will be something like this. This is the scenario in the case of ideal solutions for the Raoult's law graph. Okay, now for this non-ideal solution, for positive deviation, you will see the curve something like this, for positive deviation. So P total will be something like this. See, you are seeing it is having higher values. Similarly this line also goes something like this, similarly this line also goes something like this. Okay, so this is what PA, this is what PB. Okay, so for negative deviation what happens, you tell me, I am highlighting that with pink color. See, for negative deviation P total will be something like this, this P total will be lesser than the P calculated. This is P theoretical, vapor pressure of solution theoretical. This pink color is for observed. So this observed is for negative deviation, and this line, this also like this, and here also it will be like this. Hope it is clear how you will get negative positive deviations from the ideal solutions or this Raoult's law equation. Now now how can you identify whether a given composition is ideal or non-ideal? If non-ideal, whether it is negative deviation or positive deviation, how do you identify this? Just by looking at the composition. Just look here, if I mix two components, let us say A and B are the two components I am mixing to make a solution. If this AB both have same type of intermolecular forces, if the intermolecular forces IMF, intermolecular forces of A and B are almost same or similar, so I can say this forms ideal solution. What they will form? Ideal solution. If intermolecular forces of this A and B are almost same, after mixing also they will be having same intermolecular forces. Now intermolecular forces of A and B are lesser than the intermolecular forces present between AB. See, here I am saying the between AA and this is between BB, they are individual before mixing. So if after mixing these AB molecules are having more intermolecular forces, it means force of attraction is more between them, they comes close now, so they will show negative deviation. If they come closer, what happens? They will show negative deviation. If intermolecular forces of AA, individual AA and BB are greater than intermolecular forces of this AB after mixing, These are greater, na? It means before mixing they have more intermolecular forces. After mixing they have less intermolecular forces. Now what happens? Since they have less intermolecular forces, they will expand, they will move further from each other, so that they will show positive deviation. Hope it is clear when it will show positive, negative and ideal solution based on their intermolecular forces. Let me give you few examples here. Now I am taking hexane plus heptane. Tell me, hexane and heptane, what kind of solution it forms? See, hexane, heptane, both are non-polar hydrocarbon chains only, na? Yes. So since they have same intermolecular forces after mixing and before mixing also, because both kind of nature they have right now, so it means they will definitely form ideal solution. They will form ideal solutions. Now one more thing, CCl4 I am writing and SiCl4 I am writing. So now tell me again, chlorides, 4 chlorides, carbon and silicon belongs to, carbon silicon belongs to same group, na, 14th group. So they have similar kind of nature. So this is also what? Ideal solution. Hope it is also clear. Now look here what I am writing. Now I am writing CCl4 plus water. See, between the water molecule, we know water is polar, whereas CCl4 is non-polar, right now. So whenever you are mixing of two different kind, one is polar, another one is non-polar, so you will get a positive deviated solution. Why positive deviation? See, between polar molecule, between the water molecules, there will be intermolecular force of attraction. We can say intermolecular hydrogen bonding between the water molecules. But CCl4, no hydrogen bonding, right? So now whenever it enters in between the water molecules, what happens? The intermolecular forces becomes weaker here. So what happens? The volume will be expanded. So intermolecular forces of solution will be less when we compare with their individual intermolecular forces, right now. So I can say they will form positive deviated solution. Now I will be showing you one more example. To the water, see, when an acid and a base is mixed, tell me what happens? See, acid base interactions will be there now, so means molecules comes closer, right now. So now if they comes closer, they will give us negative deviation. Okay, so now if any interaction is present between them, they will form negative deviated solution, negatively deviation solutions. Okay, for example, here I am taking chloroform CHCl3 and acetone. So how do we identify this? Acetone means this is a structure now, yeah. So now this is a structure of acetone and this is the chloroform. Okay, so what kind of solution it will form? So just use some basic understanding of this, its structure. Like this, can I write? Yes, we can write. See, now since carbon is attached with the 3 electronegative atoms, chlorine atoms, now that makes it more create more electron deficiency. So therefore these electrons are dragging towards carbon and creates partial positive charge, partial negative charge on the carbon and partial positive charge on this hydrogen with respect to this sigma bond, right now. And these pi electrons are also taken towards oxygen, since it is more electronegative, creates partial negative charge on oxygen and partial positive charge on carbon. Now see, there is positive negative charges, so there is an electrostatic interaction between this hydrogen and this oxygen. So I can say this is intermolecular hydrogen bonding between two different molecules. There is hydrogen bonding, so intermolecular hydrogen bonding. So this makes it to show negative deviation. So this kind of examples you will be seeing in the exam. Okay, someone in the comment box. No, see, I am not just saying hydrogen bonding. So any effective interactions which make them to which make them to come closer, makes it to show negative deviation. If they goes or if they expanded, they will show positive deviation. That's it. Shivansh, I hope it is clear. Now what are the things happens? See, if we mix A and B, solution, if there is no volume change, so delta V mix is 0. This is the scenario in the case of ideal solution. Since intermolecular forces are same here, so delta V mix will be 0. For example, just for a rough understanding, I am saying that I am mixing 10 ml, 10 ml of A, 10 ml B. So we will get 20 ml of solution right now. So this is how basic understanding I am giving you. So 20 ml if you get, so this is what delta V mix means, change in volume after mixing is 0. Right now 20, like theoretical also that one only, observed also that one only, na? So 20 only, na? So delta V mix will be 0 for this solution of ideal. So for this ideal solution. But when it comes to negatively deviation and positively deviation, so it won't be 20, it may be something like 19.9 or 19.8 or lesser than 20, you can say. So that time you can say delta V mix is less than 0. Okay, so this is the scenario in the case of negatively deviated solutions. Okay, and when delta V mix is also positive, when it is, if intermolecular forces are less after mixing, so that will show positive deviation solution. Yes, yeah, wait for some time, it will be clear. Let me check the camera once. Yeah. So if delta V mix is positive, you can say positive deviation. It means what? It will become more than 20 ml now. It can be 20.5, 20.2 or 21, something like that. You can understand that is what delta V mix here means. Okay. So next thing is what you need to understand. See, what about entropy, enthalpy? This is also they will ask. So heat energy change, delta H mix will be also equals to 0 for ideal solution. It means there is no like heat released or heat absorbed for ideal solution. For this negatively deviated solution, delta H mix will be less than 0, and for positive, delta H mix will be greater than 0. Okay, and then next, what about entropy? See, this is about enthalpy. Enthalpy, negative means heat energy is released, less than 0 means released. Okay, here it is observed. Okay, the next case is what I am asking about entropy. So entropy means, see, we have these two separate components A, B right now initially. So it means in this only one type of particles are moving here, and here also only one type of particles are moving here and there. But when we make the solution of AB, now see, randomness is increased right now, whether it is ideal, non-ideal solutions. So randomness is increased when we mix the solution. So I can say delta S mix will be greater than 0 in all the cases. Delta S mix is greater than 0 in all the cases. These are the conditions that must be understood and remembered by every student who is preparing for NEET and JEE. Okay, and after this they will also ask for delta G mix in like Gibbs free energy of mixing. So this is negative in all the cases. It means it is spontaneous in all the cases. So I can say it is less than 0. Delta G mix is less than 0 in each of these cases. Hope this is also clear, right? Yes. Okay, let me move forward. Yeah, so these are the discussions whatever we did. So these are very important. You just open solutions, PYQs of solutions from any exam, JEE and NEET or any other entrance exams for +2, you will definitely see the questions on this. Okay, that's why I am covering these things. Okay, next thing is you need to know about one more point. These solutions, these negatively deviation, non-ideal solutions are there now. So they will be when they undergo deviation. So now those solutions which undergo this negative deviation may form azeotropic mixtures. Okay, so what they form? Azeotropic mixture. Both can form, like positive deviated, negative deviation, both can form azeotropic mixture, but negatively deviated solution forms maximum boiling azeotropic mixtures. Okay, mixtures. And this positively deviated solution forms minimum boiling azeotropic mixtures. Okay, these 2 points you remember. We will discuss about azeotropic mixtures in the upcoming sessions. Okay, now I just wanted to discuss few more things about these solutions, especially this vapor phase composition now, because vapor phase composition is one of the extension topic that will be asked here. So what they will be asking here is, let us say I have a solution of this AB, both A and B are volatile liquids. Upon mixing we got a solution of AB. This is the AB solution we have in this container. So I told you this is a volatile mixture, both A and B are volatile components. Upon mixing we got a solution which is also having some volatile nature. So now what happens, since it is a volatile liquid, so some of this liquid converts into like vapors, right now. So now there might be an equilibrium established between these vapors of this AB and liquid of this AB. Okay, like this I am writing. This is the equilibrium established between the vapors and this liquid. Now we know it contains component A and component B. In the liquid, if I talk, the composition of A in the liquid phase I am writing it as chi A, okay, and its mole fraction as P naught A. And here composition in the liquid phase for B I am writing chi B, and mole fraction as chi B or XB, and its vapor pressure are P naught B. Hope it is clear up to here. Now they will asking us, how can you calculate what is a vapor phase composition? What I am asking, what is a vapor phase composition? Here mole fractions are indicated for the composition of AB. XA, XB indicating what? They are indicating composition of A and B in the liquid state. Similar to that, I will be writing YA and YB for the composition of A and B in the gaseous phase. So now YB represent what? Mole fraction of A. Y represents what? Mole fraction of vapor phase of this particular composition. Ya means mole fraction of A in this vapor phase. Yb means mole fraction of vapor phase of this component B in the vapor phase. Hope it is clear. Now they will ask how you will calculate Ya and this Yb. Okay, so for this we need to understand, or we need to remember this, we need to recall Dalton's law. So what is Dalton's law? So we have, see, if a gaseous mixture is made up of some n number of gases, so partial pressure of gas, let us say ith gas, partial pressure of ith gas is equals to, what we will write? Mole fraction of that gas, it means that ith gas multiplied with total pressure, P total. That's it now. So here this is a mole fraction in what phase? Gaseous phase. So it means what I can make for this particular, here I told you ith gas, here that I is nothing but A and there it is B. So I can write partial pressure of A, gas A is equals to, I can write mole fraction of that gas A in its vapor phase multiplied with total vapor pressure exerted by the solution. That's it. Okay, so Ya I can write as Pa by P total, right now. Similarly Yb I can write Pb by P total, right? Yeah. So what is P total for ideal solutions? So P total is equals to Pa plus Pb. Okay, so this is what we got. So if you add Ya plus Yb, what we will get? Mole fraction of A plus mole fraction of B in the vapor phase is equals to Pa by Pt, Pb by Pt. So you will get Pa plus Pb by P total. So this is equals to 1. Sum is equals to 1. So this is what we will get after simplifying. Right now, hope this is also clear. This is also clear. Yes. Yeah. So let me move forward. Yeah. So let me give you one question based on this so that it will be more clear. So write a question. The two liquids, I have a question for you now. Two liquids A and B are the two liquids I have. Okay. So these two liquids forms ideal solutions at a temperature T. Okay, so when the total pressure above the solution, so P total, vapor pressure total is 400 torr. Okay, so now this is the thing they have given. Mole fraction of A in the vapor phase given as 0.4. Okay, and mole fraction of A in the liquid phase, it means XA, is given as 0.75. Okay, so they are asking us what is the vapor pressure of this A and this B in their pure state. So A and B in their pure state, this is the question they are asking by providing this data. So very simple, if you observe this, what is the data we have? P total we have, YA and XA we have. So just look into this, do we have any relation here? Yes, we have some relation. Okay, so now how do we calculate this P naught A? So we have something like YA equals to PA by P total, that's it now. So PA means I can write vapor pressure of A is equals to YA multiplied with P total, right? So P total is how much? 400. Again YA is how much? It is mentioned 0.4. Okay, and what about PA? So I can write PA as P naught A XA, because we need to calculate P naught A, not PA, right now. So P naught A into what is the mole fraction they mentioned? 0.75. So I can write it as 3/4, right? Okay, so by simplifying this, how much will get? P naught A will be, so this will be how much? 4 4 is 16, so 160 into 4/3, 160 into 4/3. So this will be how much? So you will get around 213. Okay, so 213.22, something like that you will get. Okay, and the next one is we have one more thing. P naught A we got, we need to calculate P naught B. So how do we calculate this P naught B? So now if you observe, YA is given, so sum of mole fractions is how much? So YA plus YB equals to 1. It means YA is given, so YA plus YB equals to 1 means YB will be 1 minus YA, that is 1 minus 0.4. Therefore YB will be 1 minus 0.4 means 0.6, right now. So we got this. Similarly from here, XB will be how much? This is 0.75, so 1 minus 0.75, that is 0.25, right now. So we have like YB and XB. So from this you can easily calculate here. So use a formula. What is it? So YB equals to PB by P total. Okay, so from this P naught, I want this PB, right? So I can write PB as P naught B chi B equals to YB into this one, YB into P total. Okay, so from here I want only value of P naught B. So P naught B equals to YB P total by XB, right now. So what you can do here, YB value is how much we got? 0.6 into P total is 400 and XB is 0.25, so I can write 1/4. Okay, so that we will get P naught B. So how much we will get? So remove 1 0, so 24 0 into 4, so it will be 0 6 1 and 8 9. So 960 torr we got for P naught B, and this is around 213 torr for P naught A. So this is how you can able to solve. Very easy concepts these are. So just go and solve few more questions from this particular topic, and any questions or any concept to be discussed or you are expecting me to cover, so just write in the chat box. I will be discussing the upcoming sessions. Okay, so thank you for watching. Stay connected with this NEET world. Thank you.